Good morning everyone. I am Tanushree Dalai from Civil Engineering branch. So in the previous class we discussed about the four kinds of elastic constants and the relationship between them and the derivation of relation between the elastic constants. And today we will start with the next part, which is your stress strain curve for mild steel. So in the beginning of your class, I told you that every material has its various stages and various variations of functions while it's subjected to loading system. So here you will get the knowledge about the various stages of the material. So when a ductile material like mild steel is subjected to tensile force, it undergoes different stages before failure. Okay, so here we only consider the ductile material. So let's see. So stress strain curve is the graphical representation of this stage. Then different materials may have different curves. Usually ductile materials follows similar pattern. So here is the explanation of stress strain curve of mild steel, which is ductile in nature. So here is the listed different stages when ductile material subjected to a loading system till the failure point. So here is your different kinds of stages which occur in a mild steel case. So first stage is your proportional limit, which is denoted as point A, then elastic limit, which is denoted as your point B, and third is your yield point, and yield point is divided into two types. One is your upper yield point, which is denoted as C, and second one is your lower yield point, which is denoted as capital D. Then next stage is your ultimate stress point, which is denoted as capital E. Then last is your breaking point, and it is also known as your necking point or failure point, which is denoted as F. So here is your stress strain curve of the mild steel. Okay, and these black dotted represent the stages of the mild steel while it is undergo the loading system. Okay, so here it is the proportional limit. Okay, here to here, that means from the O to A point it is obeys the Hooke's law. So according to Hooke's law, within a elastic limit the stress is directly proportional to strain. So if stress is increasing, then strain also increasing. If stress is decreasing, then strain also decreasing. That means it gives a straight line. Okay, so here a body gives a elastic behavior. Okay, so after that from A to B, it is known as your yield stress point. Okay, so as I am told you in this slide, that your yield point is two types. First one is your upper yield point and second one is your lower yield point. So here your B represent the upper yield point. Okay, and then after that it goes down, which gives the value of lower yield stress point. Then after that the D point is give you the ultimate stress point, and after that the body may rupture or fracture, which is the breaking point of the material. So first point which is your proportional limit. So what is that? So in the figure you can see that the stress strain curve of the mild steel up to the A, the stress and strain follow a relationship. Which kind of relationship? It is known as the Hooke's law. Okay, that means your point O to point A, from the origin to point A, it represents the proportional limit. Okay, so here it obeys the Hooke's law. Okay, up to the limit of proportionality, the stress is directly followed by strain. Okay, this means the ratio of stress and strain remains constant, or you can say it gives a straight line. Okay, the next is your point B. So elastic limit means up to this limit, that means point B is material will regain its original shape, is unloaded. That means while you remove the loading system from the body, it can regain its original shape and size. So point B is known as your elastic point. Okay. Then yield point. When material is loaded beyond its elastic limit, which is your point C and D, both are yield point. It will not regain its original shape while the load is removed. This will be always some deformation. So here beyond the limit of A, while you remove the loading system, then the body cannot be regain its original shape and size. So that is, you are divided into two types of yield point. First of all is upper yield point, and next one is your lower yield point. Then your point D. So D point represent your ultimate stress value. Okay. So this is the maximum stress a material can bear. That means whenever you provide a loading system to a material or a structure, so the maximum stress exerted by the body is known as your ultimate stress due to the loading system. So the value of stress developed to peak point on the stress strain curve for mild steel is the ultimate stress, and it is denoted as the point E. So you can see in this figure, this is the E point. Okay. Next is your breaking point. It is the last point of a stress strain curve which represents the breaking or rupture of the material. So the point on the stress strain curve where material is filled and is known as breaking point, and stress correspond to this point is known as breaking stress. And from the ultimate stress point to the breaking point, that region is known as your necking region. So you can see from the D point to the failure point, that region is known as necking point, and from the yield point to the ultimate stress point, that region is known as your strain hardening point, strain hardening region. Okay, so this is all about the stress strain curve of mild steel. So we have to remember all the stages of the mild steel, which is your proportional limit, then proportional limit, then elastic limit, then your upper yield point, then lower yield point, after that ultimate stress point, and your last one is your fracture or failure of the material. So today this much. So we will discuss remaining part of the subject and this chapter in the next class. So thank you so much.